These are the notes for LT6, the final learning target for the thermodynamics unit. And one of the first things you should probably do is pause me and draw this picture. Alright, what's important is that you get the letters in the correct order, and that obviously if you have a positive slope, no slope, positive, no slope, positive. So make sure you get those written down. Target says, I can predict the phase change based on whether a substance gains or loses thermal energy. So this is all about transitioning between a solid, liquid, gas, and knowing whether it's an input or an output of thermal energy that would create that situation. So let's start out, and we will refer to water most of the time just because it's simpler, but realize pretty much any element can be a solid. And as we input thermal energy, we can transition it towards the gas phase. All right, so what we'll put first is that into the notebooks. So as you transition from a solid to a gas, if we've got a block of ice and we want to vaporize it, we want to turn it to steam, it will take an input of thermal energy. Okay, we'll take an input of thermal energy. So it would be an add situation. I'll put a little plus there. Now if we are at the gas phase and we want to condense it back into a solid, that is possible, except now we would have to take thermal energy out of those molecules. So to go from gas back to a solid, you would have to see an overall output of thermal energy. So that would be a subtract situation to take it out. Alright, so the first thing we'll do is work with this graph, and then we will work with a little triangle deal, which we'll get here in a second. Assume that A is the lowest temp. Alright, so A is going to be our solid, and if we want to refer to water, then A would be ice. Alright, so we've got a block of ice. What would have to happen is if we want to melt this, alright, we would be inputting thermal energy, and B would be where we start to see the solid break down. So B could be our melting point. Okay, so we have this block of ice, we're going to add energy, add energy, energy. B is the point where the crystals start to collapse, so that at C we have become a liquid. And so if we had a block of ice in a pan on the stove, we heat it up, heat it up, heat it up, you would actually see the ice's temperature stabilize while those crystals are collapsing. Then when it gets to a liquid, you would see its temperature actually go up again until it gets to this point. So the process where we're going to take this liquid and start to transition it would be our boiling point. So we're going to take the liquid and turn it into a gas. So we would see a stabilizing temperature until we get here, and now really E through F, it doesn't matter. That is where we have the gas phase, which if we're talking water, a lot of times we call that steam. Okay, that's where we vaporize it. So we see a solid, we melt it, temperature stabilizes, now we're at a liquid. Liquid, we'll see the temperature of that liquid water go up, and then it's going to stabilize. That's where it's going to start to boil. And then we see a gas phase, all right? Now, we don't really do anything beyond the gas phase, because to turn something to plasma is not anything that's going to happen in our house typically, all right? So we're just going to call it good there. So one thing you got to make sure is that you're comfortable with this graph. All right, we're going to move this down. Next thing, we're going to look at a little triangle guy. And what's extremely important is that you don't change the points of the triangle. So have a gas at the top, kind of at the peak, I think it's called an apex, and then have solid be the left bottom corner, and then liquid is going to be the bottom right. Okay, so we've got gas, solid, liquid. Let's start with the solid, because that's always easiest part for people. We're going to do all of the additions first. So if we want to go from a solid to a liquid, we know that that would be an input of thermal energy if we want to melt something. And we know that that is what we call when we take something that's solid and turn it to a liquid. Okay, that's melting. That is an input of energy. Now we've got the pot of water on the stove. We're going to turn it to a gas. We know that we have to keep inputting energy, and this is called vaporization, where we're turning it into a gas. So that's also an addition. Now there's one step here, like we just kept vaporizing gas. Eventually we could potentially turn it to plasma, but it's possible to go directly from a solid to a gas. It happens a lot in the spring. We'll still have some snow on the ground, and a warm air mass will come in overnight, and you get to sleep in for 2 hours. Okay, this is called sublimation. And it's one of the ways that we get fog, where you go directly from that solid form right into a cloud, which is gas. All right, and that also would then take the addition of thermal energy from that warm air mass. So there's 3 examples of adding thermal energy and input. Now, if we had a gas form though, and this most often happens in the fall, so you have warm days and start to get some cold nights, and some of that water vapor in the air will deposit itself directly onto the ground in the form of frost, and that is called deposition. So that's where you would see a real quick output of thermal energy to create that solid. If we had liquid water and we want to turn it to ice, obviously we know that's freezing. That's an output of thermal energy. If we had a gas, this happens a lot in the summer. You've got a cold can of Coca-Cola, and all of a sudden you sit it on the nightstand, or you sit it on a end table, and you got a puddle of water. Okay, when that gas in the air hits the cold can, it causes it to condense into a liquid. So this is condensation, which is an output of thermal energy. All right, so I want to make sure, I think this is pretty self-explanatory, but I want to make sure that we know that if I pointed to one of these on a learning target, you would know what they are. Okay, now that we've talked a little bit more about it, we're going to put it down over here. So we know that A is a solid. From B to C, we see no change in temp of the actual substance because the ice crystals are collapsing, or solid argon even could be collapsing. Okay, we just usually deal with water. And then we know at C it became a liquid. And then we know from D to E, same thing. We see no change in temp, this time because molecules are starting to rearrange. Oops, forgot how to spell molecules. Because molecules are rearranging. They're getting ready to vaporize. And then we could say really from E and F and then beyond, it is a gas. Alright, so we have a solid input of thermal energy. We have inputs of thermal energy examples over here, and then we also have outputs of thermal energy. And that is LT6, the final learning target for the thermodynamics unit. Good luck.